Is Riya Bansal, and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So, in this video, after having talked about all the 12 rules, we are going to follow up and move forward and talk about some basic relational DBMS concepts, right? So, this session will basically focus on the fact that after talking about the small key terminologies, we also take an idea about small terms that will be used again when we move forward, right? So it's very important that we introduce the terminologies, we introduce those terms now itself so that you are able to understand and relate with those terminologies later. When you introduce these terms earlier, it helps you to become a little bit comfortable also when you read them again and again in the future slides. Okay? All right. So let's quickly get started. First, we'll go through a few definitions and then we'll move ahead. So the first thing is that a relational database management system, which is RDBMS, is a database management system based on the relational model that was introduced by EF Cord. So we know very well that RDBMS is nothing but based on DBMS only, but very specific to the relational models that we have, right? We talked about a few relational models. As you would remember, we talked about the ER model, the relational model, network model, right? And one of them was relational models, which we said is the one most popularly used after EF Cord introduced it. Okay. So what happens in relational model, the data, as we know, is stored in tables, okay, and is represented in the form of tuples. So think of it this way, that now in future, when we will have a table, okay, the entire table can be called as a table or it can be called as a relation. Here, for each and every column, you can call it as a column or you can call it as a attribute, because entity attributes are what column becomes, and a row in a table can be called as a row or it can be called as a tuple. Okay, then we move on to the fact that and say that RDBMS is used to manage relational databases, okay, because RDBMS, relational model, so it will only manage relational databases. Relational database is basically a collection of organized set of tables. So every data, the entire data set is organized into tables, right, and it is related to each other, and using which the data can be accessed very easily. Okay, now relational database, like I told you, is the most commonly used database these days. Now, so we'll introduce all the terms one by one slowly. So in relational database model, a table is a collection of data elements. Table is a collection of data elements organized in terms of rows and columns. So a two-dimensional table has everything organized in terms of rows and terms of columns. Now, a table is also considered as a convenient representation of relations. So the thing is, tables actually help to represent relations very easily. Okay, relationships and relations as in the table, okay, very easily. But a table can have a duplicate row of data also, while a true relation cannot have duplicate data. So understand, a table can have duplicates value, but in reality, a true relation cannot have duplicate data. Table is actually the most simplest form of data storage, right, that we can actually think of. Think of storing data in terms of graphs or like tree structure, right, or in ER models. It's comparatively difficult compared to everything we stored in tables, right? Because you must have seen, like, from the very start, like when you were in school, your teacher also used to take in attendance and she used to create like a tabular format, right? Whenever you enter a new society or whenever you go any place, whenever you make any reservations, everything is organized in terms of table. And that's true also. Why? Because tables are actually a very simple way of storing the data. So here is an example on the screen that you can see for actually an employee table. So we have an ID for the employees, we have the name for the employees, consecutively we have the age for the employees, and we have the salary of the employees. And all of it stored in a tabular format basically forms up the name tables, also known as relation. You can either use the word table or you can use the word relation. Both of them can be used interchangeably. Okay. All right. Now the next thing is, what is a tuple? Okay. Now a single entry in a table, right, can either be known as a record or a tuple or a row. So I'll also introduce the term record. So whenever in future we'll use all these terms, understand them interchangeably. Okay. One can be used over the other. When someone says rows and the other person says tuple, they are pretty much talking about the same thing. Okay. A single entry in a table is called a tuple or a record or a row. Okay. Now a tuple in a table basically represents a set of related data. Okay. Now usually in a row, everything is related to each other. So when we put student ID as 1, student name as Atul, student age as let's say 21, right? Something like that. So it's always about a common thing that you're talking, right? All of it is basically focusing on, let's say in this example, on the student Adam, right? So we store related data. Here 34 might be the name or age of the Adam. 13,000 might be the salary of Adam. So each and everything that is present in a row, it is dependent and related to each other. So it is a set of related data. Okay. For example, you can see that in this table, right, in the above table that we considered, we had 4 tuples or 4 rows or 4 records. And out of that, one of which we picked, and that is a single record or a row. So always remember over here, a table is formed or basically contains multiple records. Okay. In a table, you can store multiple records. Now, next we talk about what is an attribute. Okay. Now, a table, like I told you, consists of several records and rows, and each record can be broken down into several small data parts known as attributes. Okay. Let's say if I have an attribute like this, let's say 3 Adams, and this is like a record, right? Now this record can actually be broken down into 4 parts, right? Attributes is nothing, what I called was the column, right? So if I have a row, this is the attribute for, let's say, the ID. This is the attribute for, let's say, the name, right? This is the attribute for, let's say, the age, and this is the attribute for, let's say, the salary, right? So always remember that a table has several rows and each record can be broken down into several parts of data known as attributes. Okay. So a table has many columns and every column is like an attribute. So in the table that we saw over here, we have 4 attributes: ID, name, age, and salary. So whether you use the word column or whether you use the word attribute in relational model, it's pretty much the same thing. Okay. Next thing is attribute domain. Whenever an attribute is basically defined in a table, let's say for an employee, I'm saying I'll define attributes like employee, age, salary, employee ID, right? It is defined only to hold a certain type of values, which is known as attribute domains. Okay. Hence the attribute name will only hold the names of the employees table in the tuple. So the thing is, the moment I say employee names, okay, I have defined the domain of what all values will come over here, right? The moment I say employee name is an attribute, it means for sure that this column or attribute will only hold the name of the employees, right? So I've defined a domain. I've defined what exactly can you store in this. So attributes are used to define the name, like I would say the domain of that column, right? What exactly and what type of values you can store. Hence, it says over here as well that the attribute name, right, employee name, will only hold the name of the employees for every tuple. Now, it's not like you can mention this over here, which is the age, right? Each and every tuple in this attribute has to mention the name only. They cannot mention anything else. Okay. So that is what you have to remember. Now, if we save somehow, let's say the age or the address of the employee there, it will hold a violation of the relational database model. The very reason everything is done in a tabular format is so that for correct tuple, for correct attribute to store the right value. And if somehow you'll mix the value in the name attribute, you will put the address. That is like a violation of the relational database model. So you have to keep in mind that you store the right value as per the domain for that particular attribute. So while storing the value, you have to check the attribute first, right? What is the domain of that attribute? What can you actually store? What kind of certain type of values only it can hold, and that is only you have to store. Similarly, let's say if it's an age attribute, you can only store age in that. You cannot store the name, right? And that's common sense as well. Right? Here you can see name, so this is a wrong. This is a wrong example. Why? Because we have name, then we have Adam, Alex, name. Ross is also a name, but here we have stored an address, which is wrong. You cannot store a address over here. The domain is to store names. So you can only store names. All right. Okay. So then we move to the next part, which says what is a relation schema. Okay. Now a relation schema basically describes the structure of the relation. Okay. In the start, when you are defining the database, right, you don't just start putting the data, right? First, you have to define the structure of the table, right? And with the name of the table as well, and its attributes, their names and type, correct? So if you will see over here, when I am also creating a table, I don't just start putting the data, right? First, I define the structure of the table, that there will be a table, right? What all it will hold. So first I will give the table a name. So I have to mention the name of the table. Then I have to hold what attributes it will hold. Let's say ID it will hold, name it will hold, age it will hold, let's say address it will hold as well, right? So I always first define the schema, right? What does schema include? Schema basically includes the name of the table that you have to mention, right? While creating a table or a relation, then you have to mention the attributes, right? With that, you also mention what are the values to be stored in these attributes, right? So once you define all that, that means you have defined the schema, the structure of the table. Okay. Next is what is a relation key. Now a relation key is an attribute which can uniquely identify a particular row in a table, right? And this we have already talked about, the concept of keys. If you've not watched the videos on the concept of keys, I would recommend to watch it once. It will give you a good idea. So every table should have a key, right? It should have one primary key which can uniquely identify all the tuples in a table. So if it's a student table, the ID or the roll number of the student can very well become a key. So whenever you are designing the structure of the table, make sure you make one of the attributes as a key as well, because keys are very important to uniquely identify a row in a relation. All right. Next is we talk about the relational integrity constants. Okay. So there are a total of 3 relational integrity constants. Okay. This part will come a little bit in the concept of normalizations also. So make sure you understand this, right? Or if you've already watched the video for normalizations, I'm sure you must have seen that there was a term considering and talking about integrity constants, right? That we should reduce integrity constraints. So that is what it is about that we are now going to discuss. Okay. So what happens is every relation in a relational database model should abide or follow a few constraints to be a valid relation. So it's not like you can just make any relation you want, just give the relation a name and some attributes and it's good, right? No, you have to follow a few constraints in order to make sure that the relation or the table that you have created is actually a valid relation. Okay. Now these constraints that we introduce to make sure your relation is valid, right? These constraints that you have to enforce, right? They are known as relational integrity constant. Relational comes to this idea by the very fact that you are making a relational model. Okay. So now there are a total of 3 integrity constraints. Okay. Key constraints, domain constraints, and referential integrity constraints. Okay, so we'll talk about all of them one by one. The first is a key constraint. Okay, so the first thing is that you should store data only in tabular format right? And to later access the data whenever required. Okay. Now in every table, one or more than one attribute together can be used to fetch unique data from the tables, correct? And this we've talked about already in the concept of keys. That primary key is one attribute, right, which can be used to fetch unique data from the table, or you can have a composite key as well, which kind of combines 2-3 attributes and then uniquely fetch a data from the table. Okay. The key constraint specifies that there should be such an attribute in a table which can be used to fetch data for any row. So key constraints say that you should have definitely a key in a particular table so that each and every row can be uniquely identified, right? So this is like an imposed thing. You cannot just make a table which does not have a key, right? Because that's more or less like a useless data. You are just storing employee name and employee age in a table, right? It doesn't help at all. Storing that data is one thing, but how will you access that data in the future if you do not have a key? So one of the first constraint is key constraints, that every data should have or every table rather should have a particular key in that particular table or relation. Okay, so that you can uniquely identify a tuple. Now the key attributes should never be null or same for two different rows of data. So it should not be like, okay, you've defined a table, right? And the rule says that you have to define a key as well. So you made this key, but the way that you're storing data is name, Ria, 20, Delhi, 1, Aman, 10, Haryana. Now this is wrong. You cannot do that. So just defining the key is not the only rule. Making sure that the values of the keys are unique is also a rule. Value for the keys in a table should always be unique. That is the first rule. And the second rule is you cannot keep it null. For example, null now remember, even this is wrong. If you have defined a key, it should have a non-null value. Okay. Key values can not be null. Okay. Remember these two constraints that you have. And the first one was let me put it down over here so that you can actually see what's happening. The first rule was every relation should have a key. Okay. The second thing was that the values on this key should be unique. And the third was that the values cannot be null. Okay. Because it doesn't make sense if the key is a unique identifier and you're keeping it null. Right? So it says that the key attribute should never be null or same for two different rows of data. Okay. For example, in the employees table, we can use the attribute ID to fetch data for each and every employee, and no value of ID is null, and it is also unique for each and every row. Hence it can be our key attribute. Okay. So if I'm keeping an employee table, right? And if I am saying that we have an ID, we have name, we have age, and we have address. Okay. Now this ID can become a key only when it is possible and ensured that every key value will be unique and it cannot be null. If that is possible, then we have our ID, which can be our key attribute. Okay, so these are the key constraints which are introduced whenever you are using relational model. Okay. The next is domain constraints. Okay, so domain constraints basically refer to the rules defined for the values that can be stored for a particular attribute. Okay, like we've already seen that in the example, domain constraint says that the value for an attribute should always fall in that domain. That means if I'm storing the name of the employees, I can only store name and I cannot store anything else. So that is what you have to keep in mind, and the rule itself is what, like, attribute domain is what domain constraint is. I'll repeat it once again, that domain constraint refers to the rules which are defined for the values that can be stored for a certain attribute. Like we just saw that we cannot store address of the employees, okay, in the column for name because it's not possible. Similarly, let's say if I am storing the mobile numbers of the employees, it cannot exceed 10 digits. If you are exceeding it for more than 10 digits, then you are actually violating the attribute domain, which is not possible. Okay. And the last one is referential integrity constraint, which says, right, that we'll obviously study about this later, but for now just remember this example, that if I say that Supriya is my girlfriend, then a girl with the name Supriya should also exist for that relationship to be present, right? If I am saying, let's say I am friends with Aman, right, then Aman should actually exist for that friendship to exist, right? Let's say if I am saying that I work in a department of finance and the company does not have the finance department at all, then it doesn't make sense, right? So for a relationship to exist, the other part of the relationship should always be present. Okay. So the other example, it says there itself that if a table references to some data from another table, right? If I am saying that I work in a department 3, right? And in the departments table 3 refers to finance, right? So that entry should exist for 3 and finance. Then the table and that data should be present for referential integrity constraints to be true, right? You are referencing some other table and that table should actually exist. Let's say here I have an employee table. So this is ID of the employee, name of the employee, age of the employee, and department of the employee. And here is the department table. In the department table, we just have the department ID and we have the department name. And in the company, we have 3 departments: finance, business, and tech. Okay. And now here there comes an employee who says that I am employee ID 1, name is Ria, age is 32, and department is 2. Now this is right, correct? Because department 2 is for business and Ria works in the business department. But let's say if someone comes up and says this. Now this is the false idea, because there is nothing to reference over here. In the entire company, there are only 3 departments, and this is basically referencing to the 16th department, which is not there at all. Okay, so that's what it says, that if a table is referencing to some data from another table, then that table and that data should actually exist, right? Let's say the department table doesn't exist at all, and you are saying that someone works in the department number 16. So you have to make sure that the table as well as that data is actually present so that the referential integrity constraint holds true. Okay, so this is what all are the key relational integrity constraints that needs to be there in order to make sure your relations are structured and designed correctly. Okay, after this we're supposed to discuss integrity constraints, which we will discuss in the next video. Okay, this was relational integrity constraints. Next we'll discuss about integrity constraints. But just to quickly reiterate on what we did so far in this video today was that we quickly had a look about the basic relational DBMS concepts. We talked about the concept of table. Table is nothing but the other word for relation. It is just a systematic and a structural and the simplest way to store your data. Then we talked about what a tuple is. Tuple, record, row are just the words that you can use interchangeably, and it's a single entry in a table. Attribute is what the columns are. So you can either use the word attribute or you can use the word column. Okay, and every attribute has a domain. So if the attribute like name is name, then you can only store the names in that attribute. You cannot store anything else. Okay, so you always define domain whenever you introduce attributes in a table. Right? Schema is nothing but how you structure the table. What is the name of the table? What are all the attributes that are going to be exist? What are the domains of those attributes, right? What are the names of that attributes, and what are the type of values you can store? That is what means that defining the schema or the structure of the table. And the key is that every relation will have a key, and that key is basically an attribute that can uniquely identify every row in a very large data set or a table. Okay. Then we talked about a few relational integrity constraints, right? That means it's about a few rules that you have to follow to make sure that your data, right, is valid, right, and your table or your relation is valid. And we talked about three constraints: key constraints, domain constraints, and referential integrity constraints. Key constraint says that every relation should have a key, right? The values of the keys should be unique, and you cannot have null values in the key. Okay. Domain constraint says that whenever you define an attribute, every attribute has a domain, and you have to store data according to the domain. Okay. You cannot store anything out of the domain of that attribute. And the third thing is referential integrity constraints. That means if you're referencing to some other table, right, that table and that data in that table should actually exist in order to make a reference to the other table. Okay. So I hope this helps you to understand what all I wanted to teach and understand you in this process. That's why we always take a lot of examples to fully understand the idea. I hope I was helpful in making you, a little bit closer to this entire idea. I can understand that there are a lot of key terminologies that are introduced. That's why we are having separate discussions about each and every key and terminology in detail, so that you understand the overall idea. Okay, so make sure you do practice. Watching the videos and attending the sessions is one part, but the next part after this always is how much do you practice once you have been taught something. So make sure you make practice as a habit, right? You keep on practicing. Once you understand something, you make it a habit to go after the session and quickly, go ahead and revise it on your own. Maybe take a few examples, maybe define a data set on your own and try to see if all the constraints are valid or not. Okay. So after this, we'll move to the next section. Thank you so much for attending the video. I hope I was helpful in understanding you the concept, and I will meet you in the next.